Graphing a pair of equations is a good method for finding the solution to a system of equations, but it is a little bit dependent on how well we draw the picture, which can be complicated, especially at problems like example 4, where our y-intercept is a fraction, or if we had a decimal number, it can become more challenging to plot those graphs. So we also want some algebraic methods for solving a system of equations. For instance, in example 3, we have y equals negative 1/2 x minus 1, which we'll refer to as equation 1. And we have y equals negative 3x minus 1, which we'll refer to as equation 2. We want to use a process called substitution to solve this system of equations. What that means is we're going to take the fact that this first equation is already solved for y. We know that y has to equal negative 1/2 x minus 1. We're going to substitute that expression into our value for y in the second equation. That will give us negative 1/2 x minus 1 is equal to negative 3x minus 1. Once we complete that substitution, instead of having an equation with two different variables, now we have an equation that only has a single variable. It's occurring multiple times, but each time it occurs, it's an x variable, meaning we can move some terms around to combine like terms. To do that, we'll add 3x to both sides, and we'll add 1 to both sides. That will collect all of our variable terms on one side. We'll have 3x minus 1/2 x. And on the other side of the equation, we'll have all of our constant terms. In this case, that'll be negative 1 plus 1, or 0. Since we have like terms on the left, we can add those coefficients together. Keep in mind that 3 is the same thing as 3 over 1. And then if we multiply by 2 over 2 to get that common denominator, we'll have 6/2 minus 1/2, or 5/2. On the left-hand side of the equation, then, we'll have 5/2 x is equal to 0. Our last step to solve will be to multiply both sides by the reciprocal of that fraction. Giving us x is equal to 0. Once we have that value for x, we can go back to either our first equation or our second equation. Doesn't matter. I'm going to use the second equation. And in place of x, I'm going to substitute in this value that we found. So we'll put in x equals 0, and then solve for y from there. In this case, the equation is already solved for y, so we just need a little bit of arithmetic to find that that y coordinate would be negative 1. Meaning our solution would be the xy coordinate pair 0, common negative 1. We'll use the same approach in example 4. We'll take this expression that we have in equation 1 and substitute that in for our y variable in equation 2. That will give us 7/4 x minus 13/4 is equal to 2/3 x. Now we can add 13/4 to both sides and subtract 2/3 x from both sides to get all of our x terms on one side of the equation. We'll have 7/4 x minus 2/3 x is equal to 13/4. We'll need to update both fractions on the left-hand side. The common denominator here would be 12, so we'll take 7/4 times 3 over 3 to get 21 over 12. And for 2/3, we'll multiply by 4 over 4 to get 8/12. Subtracting those from one another will leave us with 13 over 12 is equal to 13/4 on the other side. And then we'll multiply both sides by the reciprocal. which will let our 13s cancel out on the right-hand side, leaving us with x equals 12 over 4, which will reduce to just 3. Now we can go back to either of our original two equations. In this case, equation 2 is a simpler equation, so substituting there makes a little bit more sense, but this process works either way. We take our x value that we found and substitute it into either of the two equations. In this case, 3 over 3 will cancel, since that's the same thing as 3 over 1, leaving us with just y equals 2. So our solution, our xy coordinate pair, would be 3, 2. In example 5, we'll do this one more time, though we have a slightly different form for equation 2. We're still just going to take what we have in equation 1, y equals 2x plus 5, and substitute 2x plus 5 in for our y value in the second equation. That means we'll have negative 6x minus, and we'll substitute in a set of parentheses here, 2x plus 5 equals negative 5. That set of parentheses will help remind us that we need to distribute that negative through both terms, meaning this will become negative 6x minus 2x minus 5 is equal to negative 5. So we'll get negative 8x is equal to 0 when we add 5 to the other side, and then dividing both sides by negative 8 will give us x is equal to 0. In this case, substituting x equals 0 is a little bit easier in the first equation because that's already solved for y, so that's just going to eliminate some steps for us. We'll substitute in x equals 0 into the first equation, but we could also substitute into the second equation. We'll get the same result. And then solve for y from there. In this case, we would get y is equal to 5, so our solution would be the xy coordinate pair 0, 5.